Rather than just talking about what a great archetype Cursor.AI is for other knowledge worker desktops, I would give you a little demo of it and do a little bit of a voice overlay. So the three desktops I'm most familiar with are what an insurance broker has available to them, what an insurance underwriter and actuary have available to them, and what a claim handler has available to them. So inevitably, when I program and use new power tools, that's what I think about is the possible analogies in the environment. So what you see on the screen here is Cursor.AI, which is an exciting new product. It is actually a fork of a product called Visual Studio Code. A fork just means they, took a copy of it at a certain point in time and went their own way. The good news is they were able to reuse a lot of previously developed software that was very well developed. I think it was Microsoft that developed it, but I don't actually know its complete origin story. But because they took a fork of it, they inherit a lot of the capabilities that it's got. So I will show you by moving the cursor around a little bit some of the things that are on here with an eye towards the parallels, and I'll probably use underwriting as my go-to, although I'll throw in some claims and broker examples, I hope, as well. I'm trying to keep this pretty short. So just to orient towards the desktop, over the left-hand side here, you can see very clearly that this is where all the files are. Just like if you're on underwriting desktop, there's typically multiple files that are in there. There are things that are generated by the user and by the system. That's pretty important as well. And then there's some other, organizational things. In every program, there should be a README file and other utility files that are needed. But most companies I've seen that have fairly modern underwriting desktops, for example, or claim desktops, have this on the left-hand side, and it's a pretty common navigational metaphor. The other things you can do here are search, right? So you can, it's very powerful and something that we're all quite used to, although I find myself using search less with this agentic desktop. And I'll explain why in a little bit. There's other utilities that are brought into the environment. What's really nice about Visual Studio Code that Cursor.AI inherited is a lot of these extensions will just work. And I wish there was a framework this rich in the knowledge worker desktop arena more broadly. I actually, a long time ago, worked with a team, including people at Microsoft, to try to envision what that may look like, but we didn't succeed. So I'll click over here and just show you that there's a whole set of extensions that can be brought in that are developed by third parties, and you could view this in the underwriting context. For example, it might be, as I had mentioned previously, an expert in alcohol liability coverage or something like that, or a particular building code expert that could find and provide tools related to different building codes. But you'd like to see a kind of a rich ecosystem where people for profit, but also just to be good participants in the community might add things. It's amazing how much people will do for free to help other people, but also because they find the work interesting. So that's what's over here on the left. It's the navigational view. I'm going to go back to the folder view and show you some of what's in here. These are the programs. So this might be sort of the data in the underwriting analogy. You might see different files. You might see a different hierarchy in here. But in this particular example, which is Cursor.AI, we see the PY files. And because they're PY files, the environment just knows that we're coding in Python. So it assumes that, and it makes all that environment assumption implicit in everything that it does. And, so nice to see that in an environment where you don't have to configure a million things, and it just sort of uses the information that you've pulled in to infer a context. And so one of the capabilities in an underwriting desktop or a claims desktop would be this type of inference. Now, I can go in here and do all the lowest level stuff I want to do with my code. One of the coolest things is tab completion, which I'll show you an example of. We all know this from our cell phones and other tools we use, but it's supercharged in environments like this. So if I want to, let's say, print something out, you can see that it's already anticipating what I might want to print out, which is a little bit of header information about the chess game that it's playing, which is what this simulation engine is doing, which is something that I wrote with Cursor.AI. And this is so nice, right? And this is what they call low entropy completion, because it can predict with fairly good accuracy whether what I want to do next. And sometimes this is nice because it just is efficient. I can just hit tab and it finishes that up. However, sometimes it's useful because I may not know what I want to do next, but it may give me different options. You can see here it's telling me different things and giving me different options. And so sometimes it's an exploration of the next activity I want to perform, and that is very powerful in an underwriting world or claim world as well. Because the modern AI is trained on sequences, the order of activities is very critical and also very flexible. And so what's really nice here is for low entropy completions, which is just a technical way of saying that it can predict with very good accuracy what the next activity is going to be, the next programming instruction I want to put in this program. It can also be very helpful when there's, high entropy, when there's a lot of possible things I could do, and it provides me with a set of possible things that I could do. So I'm going to just take this code out so it doesn't change anything down the road that I'm not expecting. The bottom section here is where you see a lot of your outputs and messages. Pretty common stuff. I'm interacting with the environment here. Cursor actually does so much configuration and interaction with the environment. It's incredibly powerful. So all sorts of little noisy friction stuff that you watch underwriters and claim handlers do all day is just stuff that the environments should be able to take care of. And why I love this tool is all the stuff I kind of assume is noise and it could do, it does, but it also gives me the opportunity to sort of customize it as well. So I'm going to show you really the cool part here. I'm not trying to make you a developer, but you can imagine that you're working away on your underwriting or claim file, and the actual agency interaction, which I'm going to bring up here. I just hit Command I if that matters to you, but that brings up sort of the agent interface. And you can see some of my prior work here, which I wanted to show you, not that it's important in detail, but it's important as an example. But over here, I'm interacting with the agent, right? You can see the word agent here on the bottom of the screen, if that makes you happy. You can also see that it's continually generating. It's asking me for feedback. It's suggesting a bunch of changes based on something prescriptive that I've done. And it's also showing me what programmers call a diff, right? So green is the new stuff, red is the stuff it would ultimately take out. And you'll see here it's both changing the code and it's changing the documentation. So anything within these triple quotes is just documentation within the software. I love this, right? Because I hate documenting my programs, but as I watch underwriters and claim handlers, I always see them writing a tome, is what one of them called it. So it's sort of covering their butts, but it's also capturing their logic and codifying what they're doing. And the reality of it is the act of doing something should be self-documenting. And in this case, it's quite powerful and very, very accurate. And it could be steered. So I know people are always worried, oh, I don't want you to put an automatic note in the file notes on the claim because, that might be something that we have to divulge later on if we're accused of bad faith, that type of thing. And so, the reality of it is we have tremendous control over these things. So what I'm going to do is I'm going to accept all the changes that it suggested. I just wanted to show you that. And it can also, execute things within the environment for me. So, one of the things that I did very early in my career was I had to rate up different products. And it was really useful, right, to actually manually with a calculator or I think we had Lotus 1, 2, 3 we could use back in the day. But to rate up a rate plan was very educational and things like that. But all sorts of math-based stuff now, I want to be able to look at how it's done and understand how it's done. But really the machine should be able to do a lot of that in parallel. And that's one of the power features here of what we're looking at. So, here it's actually running the programs that I created in a specific scenario. And it actually suggests things that it should do. Sometimes it just does them when it feels like it's, not going to make a permanent change to anything and it wants to show me that the program is working. It'll run a test case rather than, necessarily waiting for me to give it permission. Now, one of the coolest things is I can chat and talk to the code, right? So rather think of this as talking with the underwriting file. Let's say it's a energy concern that you have been underwriting for, the company has been underwriting for 7 years. You've been on the risk for 3 years. So you have all your file notes. You have all the information about how the exposure has changed, all the claims data that's available to you. And now you could just have a dialogue with it. Right, and I'll give you an example here for my code, but I'm going to say, please create a simple summary of what this code, all scripts, Python are called scripts, are doing for a new programmer coming on board. Now, coming on board is kind of hard expression, right? We know what it is if we've grown up in the United States and we know English and we know the vernacular way that things are phrased. But what's cool here is you can use whatever language you want to use. And over time, the AI can learn your language and learn what you're doing. But what it's doing right now is it's kind of creating an overview of each of the programs for somebody new coming on board. Imagine you're coming on board a risk and the old underwriter left and you're trying to get up to speed on it. Well, you could have it create very focused summaries of that particular risk by doing this. If you could, let's say you have a claim that's been open for a year and you want to kind of get a chronology of the changes that have been made. You could say share a chronology of code updates for me, but it would be claim updates for a claim handler. And it will go out and answer questions and find out information about what happened when. And it'll show you in this particular case the stream at which the updates that we made were created ultimately. And it just works, which is really powerful. You'll see down here that I'm using Claude 7 Sonnet Thinking, which is using the reasoning capabilities. You can actually click different models here, but Cursor.AI does a lot to kind of help you find the best tools, and so I just usually stick with its preference, but I may get more sophisticated at that as things come together. So yeah, it can answer questions. So I'm interacting with the agent. Increasingly, I'm spending all my time on the right-hand side here, by the way. Used to be I spent all my time in the middle of this particular screen, which kind of makes you think maybe it'll be redesigned at some point and you can actually reconfigure it with what we're doing here. But let's say now I wanted to create a new script that calculates ELOs, which is, by the way, a chess scoring mechanism where if a 1500 rated player plays a 1400 rated player, it updates both of their ELO ratings based on who wins or if it's a draw. I could go into the details there, and I would love to, but I'm not going to. Interestingly enough, I didn't have to tell Cursor.AI what an ELO was because it's using a very generally intelligent model. It knew what an ELO was. It actually taught me things about an ELO. But I'm going to say create a new script. I want something new that calculates ELOs for 2 players beginning with 2,000 scores and 100 games. And use a graph to show the results. All right, so it may not be clear to you, or me sometimes, what I'm asking it to do. It deals with ambiguity really, really well. So not only is it flexible about the different languages I might use, or language I might use, but it also is really good at detecting ambiguity that is going to stop it from working and asking me follow-up questions, which it will definitely do. It also is very good at just making assumptions and then being, making it easy for me to actually change those assumptions if I want to ultimately. So a lot of people are worried about the latency, the delay in some of this. And I have a basic rule in user interface design that if it's doing something powerful, the user doesn't mind waiting, right? Also, if it gives you updates and kind of tells you along the way what it's doing, it is going to keep you engaged, right? Just like at Disney World, when they keep the line moving and you're seeing interesting stuff, you're being entertained. The fact that as it went through the thought process, it showed me a summary of it was very, very powerful. Now, let me come over here for a second and show you that it is showing me the code it wants to change. So it's going to create this new program, which I asked it to do. I asked it to create a new script. And it didn't do anything yet, although you can see it appeared on the left-hand side here. It hasn't committed those changes. When I click on the check mark here, I will be accepting this new program that it wrote. So I just accepted that. And then, and you can see it wrote all that code from my somewhat loose description. So I, of course, have to validate it. And then it's giving me the option to very easily run it right within the agent panel. So I'm going to say, go ahead and run it. And what you'll see is it has run the program it created. And it shows what's happening here, in a pretty clear way right in the console. So after playing these 100 games, one of the players that started off at 2000 ended up at 2009.84. Usually they lop the 84F. And then the other one went down to 1990. Now this is a zero-sum game. If one player is playing another player, they go up and down by the same amount. So since they're only playing each other, which is not really the way chess works, but my simple example works, you can see that roughly speaking that player A gained 10 points and player B lost 10 points. 2000, by the way, is a very high score. So there's other parameters and things like that that you can change within the simulation. So that's pretty powerful. And let's see. It's giving me other things I may want to do. It's telling me what the script does. It says it created a graph and it put it in the outputs folder. And it knows that this is separate from the main simulation, which I had coded before I even started this video. So that's pretty powerful as well. Now I'm going to come over here and show you that that's the chart that it created. It's simulating 2,000 ranked players playing games. As I mentioned, we expect this symmetry above and below the 2,000 line because it's a zero-sum game if the two chess players are only playing each other, which of course is not real. But it very quickly kind of went ahead and created this. So you can get a real sense here that I am more describing what I want it to do, and it's doing it. I have the controls of, being able to accept. I could accept line item level changes in the code. Each diff could be accepted or rejected. And you could really see this working nicely in an underwriting or claims environment, or frankly, a broker environment. So I don't know, that's what inspires me when I look at this environment and I think, wow, I'm far more productive, but quite frankly, it's also more enjoyable because things that used to create and take a lot of friction now are very low friction. The job becomes more enjoyable. And so I think a broker's job, an underwriter's job, a claim handler's job, an actuary's job all have tremendous potential to get better. And it's really the comprehensive integrated environment, which many insurance companies would love to have but don't yet have it. I think the thing that proves the business case or makes the business case possible is the agentic stuff that's on the right-hand side of the screen here, where increasingly I'm more talking to an agent than doing the mechanics of, in this case, programming, but other things that are done. So I do hope that's helpful for you. I'm a really big believer, but I realize some people haven't ever seen an underwriting desktop or a claims desktop or a broker desktop, and other people haven't seen a programming environment, so I thought a quick map might be useful to you.